Question number 6. In this question, the percentage errors in the measurement of mass and speed are 3% and 4% respectively. The maximum percentage error in the kinetic energy will be. The student, the kinetic energy can be written as half into m into v square, where m is the mass and v is the speed. From the concept of the relative error, we can write down that the percentage error in kinetic energy will be equal to the percentage error in mass plus 2 times the percentage error in speed, as speed has a power 2 here. So this will be equal to 3 plus 2 into 4, and that will be equal to 11%. And if we analyze the given options, we can clearly see that the correct answer should be option number 1. Now let us solve the question number 7. In this question, it is asked how many significant figures are there in 427.003. The student, between any two non-zero digits, all the digits are significant, and hence for this quantity, that is 427.003, all the digits are significant, and herein the total number of digits are 6. Therefore, we can write down that for this question 4 comes out to be the correct option. Now let us move to the next question. In the question number 8, it is asked that which of the following is a dimensional constant. We have to find out that which of the quantities has a dimension. Dear students, the refractive index mu is defined as the ratio of speeds of light, and hence since this is a ratio, it is a dimensionless quantity, so it cannot be our answer. Now the dielectric constant, which is sometimes represented as K, is the ratio of forces or fields. Anyway, it is again a dimensionless quantity. The relative density, dear student, is the ratio of same dimension quantities, that is densities, meaning that this quantity is again dimensionless. The fourth option, that is the gravitational constant, which is represented by G, is actually a dimensional constant. It also has a unit which is equal to Newton meter square by kg square. And hence for this question, dear student, the correct answer should be option number 4. Now let us proceed and solve the question number 9. In question 9, the dimensional formula of the modulus of rigidity is asked. The student, the modulus of rigidity, which is represented by eta, have the same dimension as force divided by area. Now, the force can be written as mass multiplied by acceleration, while area can be written as simply length square. We are writing that to introduce the dimensions. So the dimension of force will be equal to ml t minus 2, while the dimension of length square will be L square, meaning that the dimension of eta will be equal to ml minus 1 t minus 2, and hence for this question the correct answer turns out to be option number 4. That is our final answer. Now moving on to the question number 10. In question 10, in a new set of units, unit of mass is 10 kg, unit of length is 1 kilometer, and the unit of time is given as 1 minute. We have to find out the value of 1 joule in this new hypothetical system. Now let us proceed. As we have seen in the previous question, we can write down that N2 will be equal to N1 into U1 by U2, where the variables have the usual meaning. So we can write down N1 as 1, and introducing the dimensions here we have to introduce of the joule, that is energy. Therefore we can write down m1 by m2 into L1 by L2 to the power 2 into T1 by T2 to the power minus 2. So this will be equal to 1, and the given quantities as per the new system of units are, the unit of mass is taken as 10 kg, so we introduce here 10 kg. The unit of length is 1 kilometer, so we introduced 1 kilometer here. 1 kilometer will be equal to 10 raised to power 3 meters, and the unit of second is given as 1 minute, that will be 60 seconds. Here there is power 2. This gives us a value of 1 into 1 by 10 into 1 by 10 to the power 6 into 3600. And this, dear student, will be equal to 3.6 into 10 raised to the power minus 4. And this is our final answer. From the given options also, we can clearly see that the correct answer for this question should be option number 1.